In this video, we will be discussing some of the many applications of 3D printing within the healthcare industry. We will talk about 3D printed medical tools and devices, educational materials and models, prosthesis and implants, drug delivery, and bioprinting. Very recently, we have discovered just how essential rapid prototyping and printing on demand can be. Due to the COVID-19 pandemic, a global demand for PPE and other medical devices resulted in disruption within supply chains. Because of this, the 3D printing community took matters into their own hands. Professional engineers, students, hobbyists, and us here at Fab Lab El Paso began designing solutions to various problems caused by the pandemic. Through 3D printing technology, a multitude of PPE alternatives were shared and fabricated. Some solutions that resulted include 3D printed face masks and face shields, nasal swabs, tools that help limit contact with door handles, ventilators, and even isolation pods to help with quarantining. 3D printing allows us to create medical tools and devices specified to meet our needs. Surgical instruments typically only come in standard sets of sizes. However, rapid prototyping allows surgeons to give input on the design of the tools that they work with every single day. Working with a 3D design engineer will lead to surgeon-specific, anatomy-specific, and procedure-specific tools unlike anything we've ever seen before. 3D printing has a large presence in dentistry. Instead of the traditional method of taking impressions of a person's teeth, making a mold, and casting material into the mold, dentists can now quickly scan the patient's teeth to create a computer model. From there, a dentist could create teeth aligners, retainers, crowns, and bridges. Additionally, 3D printing is used to create temporary devices like pins, screws, and even artificial bones that will resorb into the body after they are no longer needed, eliminating the need for expensive or painful removal procedures. 3D printing is often used for educational purposes. Anatomical models can be 3D printed to have incredibly realistic features. With the wide range of available printing materials, anatomical models can not only look real but feel very real, giving medical students additional opportunities to practice procedures. In fact, patient-specific anatomical models could be printed in order to give surgeons an opportunity to practice challenging or higher-risk procedures on a replica of their patient's body part. Not only will this help reduce the chance of mistakes being made, but it will also help to speed up the process. Custom prosthetics, implants, and orthotics are the pinnacle of 3D printing in the healthcare industry. Creating a prosthetic traditionally involves going in to see a specialist, taking many measurements, waiting for a prosthetic to be fabricated, fitting the prosthetic, and possibly still having to make further adjustments. With the ability to scan and 3D model someone's anatomy, measurements are taken quickly and accurately, and the process of fabricating a custom prosthetic is much faster and cheaper. This is especially helpful to those who live in rural areas and cannot see specialists without having to travel very long distances. Because there are so many printing materials available, we can also print hyper-realistic non-functional prosthetics. For functional prosthetics, like a prosthetic leg, we can use composite metals with intricate geometries that are incredibly strong but also very lightweight. This will help reduce costs and also give the user a choice of style and aesthetic. The high level of customization of implants should also improve the level of comfort to the user, and in turn reduce recovery time. The use of 3D printing to create drug delivery and health monitoring systems is being researched and developed. Currently, the Chinese pharmaceutical technology firm, Triostec, is developing a 3D printed tablet with complex internal geometries that help to control the time and dosage of the drug. Other drug delivery systems aim to combine multiple medications into just one tablet. Further possibilities include health monitoring systems like 3D printed tattoos to monitor blood glucose or oxygenation levels, and sleeve-like sensors that can attach directly to organs. So we've talked about some current applications of 3D printed tools, devices, and artificial body parts. But the future of 3D printing in healthcare is bioprinting. Bioprinting is the use of 3D printing technology with materials that incorporate viable living cells. The ultimate goal of bioprinting is to print living functional organs. The idea is to inject living cells into 3D printed structures made from hydrogel or biodegradable polymers. These structures will contain the nutrients needed for cells to grow, so that they can grow into tissue and then eventually into organs. Currently, bioprinting is in the research and development phase, but some of the major players in this industry include Organovo, CellInk, and Aspect Biosystems. Finally, it is important to note that 3D printing standards in healthcare are not yet fully established, which is a challenge for manufacturers. However, 3D printed medical devices are regulated by the FDA's Center for Devices and Radiological Health. 3D printed biologics are regulated by the FDA's Center for Biologics Evaluation and Research, and 3D printed drugs are regulated by the FDA's Center for Drug Evaluation and Research.